Radian describes the plane angle sustained by a circular arc as the length of the arc divided by the radius of the arc. Look at the following picture. It is a circle of radius r equals 1, and there is an angle A that cuts out an arc from the circumference of the circle. How long is this arc? Well, this is where radians are immensely beneficial. If you express the angle in radian, then the length of the arc is exactly A. If A equals 0.123, then the arc length is 0.123 too. Easy. The triangle has three main parts. For labeling a triangle, it's important to identify where the right angle is and where theta is. First, for labeling the hypotenuse, we gotta know that this one is placed right in the opposite of the right angle, and it's the longest side of the triangle. Also, the right angle, it's always the opposite leg. So we gotta know that this one is right opposite to the hypotenuse and to the theta angle. The adjacent side of the triangle is always going to be touching the theta angle. Also, it's important to note that these labels might change according to the different type of triangle, so it's not always going to be this way. Also, we need to know that when they give you a triangle labeled with angles and sides, it's important to be aware that lowercase letters represent angles and uppercase letters represent sides. Just think of it this way. Let any triangle sit on its base with the vertex angle pointing upwards. Now slowly increase the vertex angle and know what happens to the other angles. They are getting smaller, aren't they? Keep going until the base angles are 0 degrees. What's left? A straight line. And we all know that straight lines is 880 degrees. The Pythagorean theorem deals with the length of the sides of a right triangle. The theorem states that the sum of the squares of the length of the legs of a right triangle A and B in the triangle shown below is equal to the square of the length of the hypotenuse. To solve a triangle is to find the length of each of its sides and all its angles. The sine rule is used when we are given either A, two angles and one side, or B, two sides and not included angle. The cosine rule is used when we are given either A, three sides, or B, two sides and the included angle. Area can be defined as the extent of a surface or a piece of land. Perimeter is the continuous line forming the boundary of closed geometric figures. Before we start trying to find more exact measurements of the area of a triangle, we need to define a few terms. Vertex of a triangle is the point at which two sides of a triangle meet. Altitude of a triangle is the perpendicular segment from a vertex of a triangle to the line containing the opposite side. Knowing this, we can define that the height h of the triangle can be expressed as b sin c. The area of a triangle can be expressed using the length of two sides and the sin of the included angle. Area of a triangle equals 1/2 a times b sin a over sin of c. You may see the reference to as the SAS formula for the area of a triangle. There are three versions of how to get the area of a triangle. Here is a brief explanation of it. P equals the ratio of a circle's circumference to its diameter. The value of P is a special number based in geometry and used in trigonometry for the study of triangles and circles. Its discovery is historically attributed to ancient Greece and named after the 16th letter of the Greek alphabet. The P value represents the ratio of the diameter of a circle divided by its circumference. The value of p is a rational number approximately equal to 3.14. P demonstrates several significant advances in mathematics. The unit circle is used to understand sine and cosine of angles found in right triangles. The unit circle has a center of the origin 0, 0 and a radius of 1 unit. Angles are measured starting from the positive x-axis in quadrant and and continue around the unit circle. Here is illustrated the example of a graph of sine. Also, there is an example of a graph of cosine. And finally, here is a graph of tan. A periodic function is a function that repeats its value in regular intervals or periods. The most important examples are the trigonometric functions, which repeat over intervals of 2 periods. Here is an example of it. Finally, I'm going to explain the meaning of this sinusoidal function. Y equals a sin times b times x minus c plus d. A equals amplitude, b equals cycle from 0 to 2p, period equals 2p over v, d equals vertical shift or displacement, c equals horizontal shift, and sometimes called phase shift when b equals 1.